So at Echogen, our view is that we're going to need every megawatt that can go on the grid, and we're going to need to use every megawatt that's on the grid in the most efficient way possible. We've been focusing the past 5 years on our energy storage technology, but we see a prevalence of applications where the core of our technology is going to be utilized in different ways. So what Echogen does is we design power systems, power conversion systems that utilize supercritical carbon dioxide as the working fluid. This means that we use carbon dioxide in place of where you think traditionally of steam in an application. There's a little bit of irony in the fact that we use CO2 to reduce CO2 emissions in the world, and we find that pretty compelling in our story. The energy storage application that we have has been gaining a lot of momentum. We have some commercial projects underway now, but we see more and more application of our technology in waste heat recovery, particularly on simple cycle gas turbines, as well as in industrial heat pump applications for electrification of industrial processes that typically could not be served by heat pumps. So as the energy markets continue to evolve and the energy storage technologies continue to evolve, we're very excited about how our technology can really integrate into all sorts of applications in the marketplace. So we're really excited about Project Polar in Alaska. We have some great partners in Fairbanks, which is an area that has very unique energy challenges. They have difficulty securing additional gas supplies for natural gas generation, and so they rely on their existing coal generation as well as diesel peaking units. They also have a single point of interconnection to the south of Alaska, which creates some resiliency and reliability challenges for their large industrial customers. Project Polar is installing long-duration energy storage, one of the largest projects in North America outside of Fairbanks, in a way that's going to really support the customers in the area, lower electricity costs, improve air quality, and overall improve the reliability of the grid. From a cost standpoint, this project will nearly eliminate the need for peaking generation in the area that exists, significantly cutting costs for the rate base in the area. What we learned through this project was that community engagement at an early stage is very important. We got the right stakeholders involved in the project. We built the right team, including local partners and local constructors. And we really developed a coalition of people that began to believe in the technology, believe in the project, and then really developed a compelling argument for why this technology could solve a lot of the energy challenges in the area. So we're really excited about the partnership with Westinghouse. Westinghouse brings a lot of credibility to our technology from the standpoint of being able to actually deploy large capital projects. Westinghouse has a large engineering organization with thousands of engineers, and they're very experienced at deploying power projects that need to work the first time correctly every time. Westinghouse also brings some technology to our energy storage solution. They have some novel technology on the high temperature reservoirs that we use in our pump thermal energy storage solution. And they're overall a partner that can go to market credibly with utilities and really help develop a pipeline of long duration energy storage projects that are going to prove worldwide that LDES is the right solution in a wide range of applications. So this is a question that a lot of people are considering lately with a potential renaissance of gas power generation. Where does new technology, new long-duration energy storage technologies fit in the marketplace? As we mentioned before, we're going to need every megawatt that we can put on the grid, and we need to use every megawatt that's available on the grid. We don't believe that long-duration energy storage and gas generation and other forms of power generation are mutually exclusive at all. We believe that there's going to be an enormous mix of technologies and that they all really complement each other. Our project in Alaska is a great example of long-duration energy storage that, while it enables wind technology to be easier integrated into the grid outside of Fairbanks, it really also just firms up the existing generation assets and reduces the operating costs for the utility. We also see opportunity to integrate energy storage into existing infrastructure. such as nuclear power plants and data centers, in new and creative ways that helps the grid become more reliable, reduces interconnection queue times by reducing peak demand of data centers, and overall just creates a more reliable, resilient grid across the world. So our industrial heat pump program is very exciting. It started this year and it goes for the next 3 years. We're in the design phase, which will wrap up in 2026, and then we'll move into construction and installation at our headquarters in Akron, Ohio. We'll be commissioning that system and then testing it into 2027. And the end result will be an industrial heat pump that can achieve temperature rises that no other heat pump currently can, on the order of 400 degrees Celsius. We see this driving the cost of electrification for many industrial processes down to a price point that hasn't been achieved previously, and really makes electrification and decarbonization for industrial users a much more appealing option.